it's going to work, but if it doesn't, we'll figure it out later. So did everybody successfully install Anaconda? Perfect. So Anaconda is really nice because it comes pre-packaged with basically everything you need to get going with Python. And now you could actually do R with it too, which is a relatively recent feature, but it's really helpful. And it comes packaged and self-contained with a lot of the tools and most commonly used packages and libraries that you might encounter, which is really helpful. So most people probably installed the graphical user installation of Anaconda, but in any case, you should all have an icon that looks like this, like your Anaconda navigator. So if you just open that up, it'll take a few minutes to initialize, and then a list of a bunch of different programs that are included in the Anaconda distribution will show up. So these are all of the ones here. So it comes pre-packaged with Jupyter Lab and notebooks. Spider, you could think of Spider as like the RStudio for Python. It's basically the same type of environment to develop Python code in. And then you could actually get RStudio with it as well, if you want to. So what we're going to do everything in Jupyter Notebooks. So we're going to go ahead and launch Jupyter Lab. And we're all going to sort of code and create the notebook and lesson together as we go. So the lesson that I have I have it here, but I'm going to write it out in full, sort of alongside you guys, and you guys just follow along. So you could install different kernels. That's what Jupyter calls it. So for example, I could start an R session notebook if I wanted to. I could start a Python 2 notebook or a Python 3 notebook. The installation that you guys have presumably is all for version Python 3. So we're going to go ahead and start in Python 3. I wouldn't, for people just starting out in Python, I wouldn't recommend getting Python 2. As of 2020, they're not supporting it anymore. Everything is moving to Python 3. So I would just stick with Python 3. And so this is sort of what the notebook looks like at first. It's pretty blank. On the left side, hey, hold on. On the left side, you see basically your computer structure. So Jupyter is now patched into your computer, and you can navigate through it like you would in your Finder or your like My Computer Navigator, right? So you could just go for files. When you open it, you have this notebook here, which is called untitled.ipynb. We haven't called it anything yet. So we might want to give it a name. So we could just right click on that, go to rename, and we could rename this notebook. Maybe we'll just call it Intro to Python. Hard for you guys to see. Yeah, Intro to Python. I can't go any lower than that, but. So IPYNB is IPython Notebook. So this is the extension for all notebook files. So the thing that's really cool about notebooks, I'll just give you guys a really quick primer before we delve into the actual Python. So if you see this cell here that says code, you actually have a few different options here. So you could have code cells, but you could also have markdown cells. Mark is like plain text. Markdown is plain text. So if I switch this first cell to markdown, it's not a code cell anymore. I could just type in here, this is a markdown cell. And when I render it, which means run the cell, which you can do on any keyboard by pressing Shift Enter, it'll run that cell. You'll see that this is now just plain text. It's not code. And the beautiful thing about this is Markdown has a lot of quirky syntax things that allow you to format the text in particular ways. And we'll have entire Markdown tutorials. But for example, I could create a header by adding a hashtag in front of it. I can bold text with 2 asterisks. You could italicize text. You could create is a numbered list. You can create lists. And then if I run this cell, you see all of that formatting is preserved. Yeah. With a single asterisk on either side of the text you want italicized. So this is just like the briefest introduction to Markdown. You could insert hyperlinks and images and like all kinds of crazy stuff. But this sort of highlights one of the beauties of Jupyter Notebooks, right? You could have text that explains in detail what the analysis is, and then code cells. And then when you run code cells, the output appears right below. And then if you go to File, you could export Notebook as like a PDF, for example, and all of that text, code, and output gets rendered in the PDF, and you could share it with collaborators, right? So you don't have to copy and paste output from R into a Word document, deal with the formatting, and all of that kind of stuff. So it's a really brief introduction to Jupyter Notebooks, but really kind of facilitates collaboration and like documenting your code and your workflow and your analyses. And we'll have more detailed breakdowns of like Markdown and stuff in future tutorials. But everything that we do in Python is going to be done in these sort of Markdown or Jupyter Notebooks. So I'm going to go ahead and I'm going to create a Markdown cell. Well, I'll do it in this cell. So I'll turn this cell to Markdown, and then I'll just create a header, February 5th, Intro to Python. And so that's today's lesson. You could create subheaders as well by just increasing the number of hashtags. So the first thing we're going to learn about is the interpreter. So the interpreter is sort of like what is actually reading the commands that you put into it, right? When you run a line of code, something on the computer has to read that code and give you the output. And so that's what the interpreter does. And so we could actually insert another one. With every increasing hashtag, the text gets smaller and smaller. So you could easily format headers that way. So the first thing I want to talk about with Python is just like most languages, you can use it as a calculator, right? So in any code cell, you could just put, for example, 2 plus 2. Yeah, I think I could do that. And then hopefully, can't really scroll. Can everybody see that? I could probably, that's exactly what I was going to do. Perfect. You guys don't have to do that. So everybody can see that? So you could just add sort of an arithmetic operation to a code cell. And if you run it, you'll see the output appears right below it, right? And so that's sort of this interactive nature of the IPython notebooks. You put the code in, run it, and the output appears below it. You could put any number of these. So 2 times 3, 6. You could do exponents in Python, and the way that we do it is not really the same way that we do it in other languages. You do it with 2 asterisks, like multiple asterisks. So 2 to the power of 3, that will intuitively return 8. And then I'm not going to go through division. I think you guys get the point. There is this neat operator that I'll just briefly introduce you guys to, which is called the modulus operator, which is the percent sign. This is not Python specific. This is brought over from Java back in its heyday. But what it does is it returns the remainder of a division. So the modulus 10 modulo 3 returns 1, because 3, 6, 9, and then there's a remainder of 1 before 10. So it returns the remainder. One thing that's useful to mention here is you could add comments in code cells if you want to document your code by including a hashtag. And so this is the modulus operator. It returns the remainder of a division. So when you run that cell, it's not running those comments, but it allows you to just document what the code in a particular cell is doing. So this is just an intuitive reminder for us of what the modulus operator is. Why is this operator useful? Well, what if you want to know if a number is even, for example? Then you could use the modulus operator to know that the remainder should be 0 when you divide by 2, for example. So you could use this in a variety of different scenarios. We're only introducing it to show you that Python could do this sort of stuff. You'll notice that all of the operations here are integers, right? So there's no decimal points here. They're all whole numbers. So more specifically is we might want to actually call this section math with integers. Because computers deal with other types of numbers too, right? And so for the next section, I'm going to go ahead and insert a markdown cell after this section. Math with floats. You can think of floats as decimal point numbers. So if a number has a decimal point, even if that decimal is 0, it's a floating point number. And so the first thing that's useful to know is operations involving floats always return floats. So what do I mean by that? I mean, if we do 2.0 times 3, we know the answer is going to be 6, but Python is going to return 6.0. It's going to convert that immediately into a floating point number. So any arithmetic operation that has a float in it is going to return a float. And this is important, right? Because some functions or libraries or things that you might want to do might require the input to be of a particular type. Some things require the input to be an integer. Other things require the input to be a float. So you could, of course, convert floats to integers by rounding, or you could convert integers to floats by either doing some operation on it that returns a float, or, as we'll see later, actually like directly convert the type of the object. So there are more examples in the handout. I'm not going to go through all of them. But just for example, like 10 divided by 3.0 will return some really long float, and you could round that if you wanted to, but this would be the default output. In terms of sort of the math that you could do with Python, it's pretty intuitive. It's very similar to what you might do in any other language, or just punch in on your calculator. The key here is to understand what is being returned by these different operations. Is it a float, an integer? And you have complete control over those things. So I'm going to insert another markdown cell. And then we're going to start getting into the different data structures of Python. Data structures is just like a fancy way of saying a thing that holds data. There's a bunch of different ways to hold data. A CSV is a data structure. A text file is a data structure. Python and most languages have their own ways of holding data. And we'll talk about some of those. The simplest, of course, is just as a variable. And so a variable in Python, for anybody that's dealt with R, is done in a really similar way. So let's say you wanted a variable and you wanted to call it year. Well, to year, you set it equal to what you want that variable to be. So year equals 2019. And so we might want to create another variable like name. So we're defining two variables in this cell, right? So the first, the variable year, we've set equal to 2019. So that's an integer, right? It's a whole number. And then name, we set it equal to James in my case. You could put whatever you want. This is a string. String is a particular data type in Python, not only in Python, but many languages. And we represent strings by surrounding them in quotes. Now you could use single quotes and double quotes interchangeably. The reason it's helpful to have both is because sometimes you might want to have a whole string included in double quotes, but maybe substrings included as single quotes within it. So it allows you to like nest strings together in convenient ways sometimes, but just know that in most cases, single quotes and double quotes will give you the same thing. They both return strings, which are usually letters. but it could also be like non-alphanumeric characters like Latin symbols or like weird Unicode things. Or you could have numbers as strings if you want. It totally depends on what you're doing with it. But in the classical sense, as biologists, we might think of strings as like the levels of a given factor in an experiment, right? Like the treatment levels that we've applied to something. We would typically encode those in a column treatment, and each level would be a factor level, and that would be a string in most cases. In R, this is called a character vector. So we'll use the first function, which is the print function, on one of these variables. So we want to print year. Print really simply just returns year is not defined. I didn't run that cell. So that error highlights something useful about Jupyter Notebooks, which is that every cell sort of depends on the previous runs, right? So you're only defining in the environment the cells that you've actually run. So I ask it to print year, and then notice that by printing year, it's not just printing the word year, it's printing what I assigned to the variable year, right? And this is important because it gives you complete control over how you name things and what their values are. So in this case, it's returning the value of year. We could do the same for name if we wanted to. Another helpful thing is maybe we want to verify what the type is, right? So we said there's integer types, there's float types. We now introduced strings. So maybe we want to know the type of the variable name. So we could use this other function, which is intuitively called type, and just give it the variable that we care about. So in this case, I want to know what the type of the variable name is. And it returns class str. Str is short for string. So it's telling us that the value that's assigned to the variable name is a string. Can everybody see that? You don't have to pass variables to the type function. Of course, you could pass just raw values. So maybe I want to know what the type of 2.0 is. You could just run that and it'll return type float. We included this decimal point here, so Python correctly interpreted that as a float data type. Good so far? Finally, it's really helpful to know some details about a particular function. So let's say you don't know what the print function does. And this applies to any function. You could type help print. And it'll just print all of the details for you right underneath, right? So help on built-in function, print in module built-ins. So it tells you the module that it comes with. In this case, the print function is included with Python natively. It's not part of some external package that you had to install. And then it just gives you some details about it, like some value, what the separation might be. We won't go into details about what all the arguments are. Yeah.
Is there something similar to the environment that's in R so you can see all of your objects and your data that's in there, or do you actually have to call it up with code?
There are ways to do that in Python. Go ahead.
Yeah, but I'm sorry.
No, go for it.
Yeah, so there's no like kind of helpful pane in Jupyter like there is in RStudio that lists all your variables, unfortunately. Yeah, there is a Python way to do it. Yeah. It's kind of like an ugly line of code.
Yeah, okay.
It's like locals, brackets, keys, brackets, but generally it's kind of like keep track of your own variables in that sense, which is a bit less friendly than R.
Oh, okay.
Yeah.
We could include that line of code later on, but it uses Python has a bunch of variables that it defines that are part of the environment, and you could access those variables directly. And so you could print out those variables, and then it'll tell you everything that's defined. Yeah.
Is there a key to repeat what happened in a previous cell? Like if you want to fix something, a code in the cell, is there like a key to regenerate what you have done in the first one and a new one, or you can just go back to that one?
You could just go back to it and edit it and then rerun it. there's a way. Are you saying like maybe you want to redefine a variable?
Like using the up and down arrows to bring back the last line of code. And
oh, that doesn't quite work in Python in Jupyter notebooks because of the way that they work. You can navigate between cells just using the arrows. So it depends on how you decide to structure your code cells. You could always. Do you know of an intuitive way to do that in Jupyter? I don't think you can. Use like on the command line, you could use the up arrow to cycle between previous commands. Yeah. But that's kind of the purpose of Jupyter Notebooks in a sense, because it keeps this running documentation of everything that you've run. And so you're not losing previous commands as long as you make sure that they're maintained in some cell in the notebook. One thing I will mention is once you delete a cell, if it has code in it, that code is gone. So there's no like trash bin that you can just recover it from. So just make sure that you don't inadvertently delete cells. And they make it hard to do on the keyboard. There's a keyboard shortcut to delete cells, but it's not something that you'll just press accidentally.
So Jupyter Notebooks are kind of designed to be like written and read by other people, like in a very linear fashion. And that's why they're so popular in sizes, because you basically write out a whole analysis step by step, right? So you don't really get like Spider, other program James mentioned. So this more of a limitation of Jupyter Notebooks.
So variables are all well and nice, but now we're going to get into like some actual data structures that you might encounter and that you're going to see literally everywhere in all stretches of Python code. Lists and tuples, or maybe tuples. I don't think it's settled on how to pronounce that. So first, lists use square brackets. We'll emphasize that because different data structures in Python are defined using different types of brackets to enclose them. Whether it's circular, square, or curly is what determines the type of data that that thing is going to hold. So what we're going to do is we're going to create a simple list that we're going to call fruits. So just like variables, lists have to be assigned to some name, right? So we're creating this variable fruit, and we're going to assign to it a list data structure. So we open up our square brackets, and then now we could add elements into this list. That's literally the first one I have down here. So I'm going to use single quotes. Apple, orange, mango.
You're biased towards simplification?
Apparently. I'm just following what I have here. So we run that cell. Now we have this thing called fruits. Maybe we want to look at it to make sure that it is exactly what we thought it would be. So we could print out fruits. And in the same code cell, let's just go ahead and print out the type for that object. So we see that by printing fruits, it prints out literally the list that we defined and assigned to the variable fruits. And then the class in this case is list. So it's not a string, it's not an integer, it's a list. It's its own type. Even though this list is made up of many different elements that are of type string, right? And we'll talk more about how to sort of unpack that in a second. So, yeah.
You can also do the fruits alone, and the default command will be print, right? Like R. Like if you just type fruit, it will return what is this?
Yes, 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 yes. But what happened here is this is sort of a quirk of how Jupyter Notebook works. If you want a cell to print multiple things on separate lines, they each need to have a print statement. If I just type in fruits, but this is followed by something that's printing, it'll only print the thing that has the print statement. But if I only type in fruits and there's nothing else in that cell, it'll return that list. So if you want a cell to print out multiple things, then you could have multiple print statements. Alternatively, I could have just included fruits here, and it would have also returned it after assigning it. So you also have control about how things are displayed in the notebook. for now, because in this case I wanted multiple things in the cell, I included print statement to each of those. Yeah.
I should tell people about the
Yep, that's a really good point. So we assigned this thing called fruits. When you have a lot of variables, Python is actually keeping track of what's defined, even if we can't intuitively see all of the things that are defined. But you can type part of it and then hit tab, and it'll complete it. And if there are multiple things that complete with a given set of characters, it'll give you a drop-down list of all of the things, and you could use your arrows and navigate and select it. So yeah, thanks, Ruth.
It'll also do it for files, right? If you're looking for
Yep.
files that are in your
Similar to command.
Yeah, same idea, same idea. So it's important to note that lists can hold data of many different types, right? So we might have a list that, for example, has an integer as its first element, and then maybe has a string as its second character, and then a floating point as its third element. And so if you define it that way, that's fine. Python will just take whatever you put in that list and just return it to you.
if you don't use the quotations.
If you don't use the quotations, you're going to get an error. And the error is going to be that variable. Well, in this case, it's invalid syntax because that's an actual character, but it'll say Python is not defined. So it's going to look for a variable that you've assigned named Python. In this case, we don't have that variable, so it's saying that doesn't exist, right? So by putting it in quotes, we're saying this is a string. It's not a variable. We want this element to be a string that's called Python. Does that make sense? So I'll just rerun that. And then finally, I'm only going to briefly touch on this. Fruit tuple. You could do the same thing. So apple, orange, mango. So a tuple is basically like a list. It holds a bunch of different data types. The difference is that we define them using circular brackets instead of square brackets. But they're used a little bit differently than lists in that they're immutable. Once they're defined, you can't change their elements. So what goes into the tuple stays in the tuple. So you can't, like, for example, go into this and say, oh, you know, I want to change apple to pear. It won't let you. And we'll see a real world example of that in a second. They have very particular use cases. Most people will program in Python their entire lives and never use a tuple. But they exist, and so it's important to just be aware that you might see the word thrown around. I've used a tuple once. Twice now, yes. Markdown. So indexing, lists, and strings. So we often don't just want to define these different data structures. We want to do things with them, right? They're holding data. These data are changing. We want to use these in different ways throughout our programs. So we need to know how to, like, do things with the lists that are helpful for us. So the first thing you can do, print fruits. So remember, if we just type this in, it's going to return the whole list. But what if we don't want the whole list? What if we only want to know what the first element in the list is, which we know to be apple, right? You could follow the name of the list with square brackets and then insert the index of the element that you want. So the important thing to remember here is that not indexing, but counting starts at 0, right? So index 0 is the first element in the list, whereas 1 would be the second element in the list. This is done for unintuitive programmatic reasons having to do with, like, returning the length of the list in a more intuitive way, but a lot of programming languages start counting at 0.
Our users,
Yeah.
it takes a bit of
And so it just returns apple.
Was that like, so you know how R you index with rows and columns?
Yeah.
Here it's just a single, am I looking at a row, am I looking at a column, or is it just, how does it first create your variable?
Yep. So that's a really good question. So it's important to remember that the list we created is one dimensional.
Okay, yeah.
You can create nested lists. So where each element of the list is a list. And then in that case, you would have to use first set of square brackets to say, I want the first list. And then the second square brackets would be the element in that nested list, right? So you could have really deeply nested lists where you need like 10 indices to get to where you don't want to do that. The point is like, this is a one-dimensional data structure that we've created here, but you can have two-dimensional data structures like nested lists, or as we'll see later, NumPy arrays, which more similar to the way that you would index things in Python, require row column indices to retrieve specific elements out of them. So the answer is yes. It's just Python. It's just a little bit different. Yeah.
Out of like a list, like let's say you want to do two of them, how would you be able to do like apple and orange without? Is that possible?
You mean just have a list with two elements?
No, you have a list with four elements, but you want to not just pick one of.
Yeah, we're getting to that in a second.
Yeah.
That's really good question. So what do people think it's going to return if I ask for the type of fruits 0? What should that return? String. Yeah, exactly. Right? Because we're asking for the type of the first element in the list. So not the type of the whole list, but the type of that specific element, which we know is a string because we defined it that way. There we go. So now we're getting to Urfa's question. Make sure that you guys can see that. So slicing lists. So we could print, for example, fruits. And then instead of passing just a single index here, we could say, give me all of the elements from the 0th index, colon, to the second index, which is actually the third element, right? But it's exclusive. So it's like 0, 1, 2, 3, but the 3 is not actually included, right? Does that make sense? Yeah?
So it starts indexing at 0, but
Which
the
is
second
apple.
argument is exclusive. So if we say 0:2, it actually means 0, 1, stop.
Yeah.
So it's not including what's
So it's exclusive. So it's inclusive on the first element, but exclusive on the last.
Yeah. It's confusing, but there's like a bunch of programmatic reasons for it.
These are just like little rules that you have to remember, specific to Python, maybe. Not technically true, like other languages do this, but a little bit different from how R does things.
Yeah.
R is inclusive in both cases. Similarly, we could just ask for fruits 0, colon. This would actually just return all of the elements. When you don't specify an endpoint, it goes right to the end of the list, right? So 0, colon is the whole list. And then you could get a similar effect by doing colon 3. In this case, the fact that there's no element here means right from the beginning of the list up until exclusively this element, which in this case is 3, but there's 3 elements in the list, and so it returns the whole thing.
You wanted apple and mango, you would do 0, 3? No, 2.
No, you wouldn't. You can't do that to lists. You could do it using a for loop. You could iterate over every element in the list and say if the index is 1, or well, if the index is 0 or 2, return them. But if it's not those things, it won't.
Makes me want
What? Well, no, there are other data structures that are more that are better able to handle things that you might want to do that with. Yeah.
I don't
So
know why you would, but you could make a new object that had like the first index 0, comma.
absolutely,
index 2.
you could create a new list that is made up of only those list elements that you want.
It's worth remembering that Python was developed by developers and ours developed by statisticians. So lots of Python specific stuff like this is basically designed to computer science setting, and very rarely is computer science how to listen to that, and that. Whereas as researchers, we're often like, I want these data points and I don't care about the rest. So, but the cool thing about open source languages like Python is, like James said, people can develop new object types.
Which is basically NumPy.
Yeah.
Finally, you could pass negative indices as well. So print fruits -1 would return the last element of the list. So the negative just means start counting from the other end, right? And go in reverse. So you could access lists from both ends. Well, you don't start counting from 0 if you're going in reverse.
Is why would you need to?
Yeah. So lists support reassignment. Basically what that means is I could say I want the second element of the fruits list to be banana. What's that? Because I hate my mango. And then if we print fruits, we'll see that mango has now become banana, right? So you could dynamically rename or reassign elements in your list. This is the difference between a list and a tuple. I can't do that in a tuple. If I tried to reassign the mango, it would say no, like you really want this mango. It just wouldn't allow, that to happen.
Why don't we get some green in there?
And then strings work the same way. So
You can have a green apple.
Ugh,
Have a green banana too.
those are more appealing.
Strings be reassigned.
no, you can't go into a string and say, I want to change this particular letter to a different letter. What you could do is two things. One, convert the string to a list. Then every letter becomes a list element. Reassign the element you want to a different letter, and then change the list back to a string. That's the complicated way. The simpler way is using a particular function that is associated with strings called replace. So you could do myString.replace and then replace the particular character. But it's going to replace every instance of that character in the string unless you're careful and do some stuff like regular expressions or whatever, which we'll get into in the more intermediate lessons. Like for now, if you really wanted to do it, if you want to return, like just change one element of a string, take the long way, convert it to a list, and then change the element, convert it back to a string.
But since that's a huge problem in DNA sequence land, again, there's really specific packages that create certain kind of string objects that do allow for reassignment. If you're trying to like convert every base complement, lets you feel like restricted by the limitations of like the base objects.
You don't have to, is that not okay if I just let her wander around? It's clearly faster than
It should be. But it is, yeah, it is worth knowing the limitations of the base objects, but like don't feel like you're.
Finally, you could index them the same way you would a list. So if I index it from position 1 to the end, it basically returns everything except the t, because the t in this is index 0. So you could slice strings in particular ways. If
Does it count the space between the words as well?
yes, spaces are considered characters. Okay. Finally, my favorite kind of data structure, dictionaries. probably maybe the most useful data structure in Python, but the one that people are less inclined to use, I think. Like, so many times you'll read people's Python code and be like, you know, this should be a dictionary. Instead, they created the most complicated series of nested lists when really all they wanted was a dictionary. So how do dictionaries work? Let's create a dictionary called fruit colors. So dictionaries are assigned using curly brackets. So we start it using curly brackets. And what? Is that the Canadian spelling?
Yeah.
I don't actually know. So dictionaries store key value pairs. So what do I mean by that? So banana would be our key, for example, and then banana, we separate key value pairs in dictionaries with a colon. So the banana in this case is the dictionary key, and then the value would be, in this case, the color, so yellow. So we're saying that bananas are yellow, right? Bananas are associated with the value yellow. And then we could separate different elements in the dictionary with commas, and then just add more. So apple, in this case, we'll go for a red apple. And then orange, suppose we'll go with orange, right? So this is basically the syntax for a dictionary. So you have these keys, and these keys are assigned with values. Now, these values don't have to be strings. These values could be integers. They could be floats. The values could be lists. The values could be other dictionaries. Like, you could make these values whatever you want. The keys, though, should be strings.
They can be integers.
They can be integers. Yeah. Does that make sense? But the values can be whatever you want them to be. And that's really helpful. It's especially helpful to know that the values can be lists, because that means for every particular key, you could store many different attributes or properties of that key in a list. And as long as you know the order that you put them in, then you know exactly what all those values are, and you could just retrieve them dynamically as you program. And we'll go into some of that. So for example, if I want to know,
Run the cell.
oh yeah, run the cell. If I want to know, I'm going to print it. If I want to know the value associated with a particular entry in the dictionary, you could just type that out in square brackets. Right? So notice this is a little bit different than the way that lists work. You're not using an index here to retrieve the element. You're using the actual key that you assigned in the dictionary. And then it will return yellow, because that's the value associated with that key. You could add elements to a dictionary. So fruit colors, let's say lemon equals yellow. So what we want to do is we want to add an element to fruit colors. We want the key to be called lemon. We want its value to be yellow. And then just to confirm that that works, we're going to print fruit colors afterwards. Right? So now we see this additional element in the dictionary tacked onto the end here. Lemon associated with the color yellow. But it's important to remember that only one instance, there's a better way to say this. Dictionaries do not support duplicate keys. Right? So if I now basically copy this same line and say, no, wait a second, my lemon's not yellow, it's red. It's not going to add another element to the dictionary with lemon equals red. It's going to replace the one that's in there. So print fruit colors. So now lemon is associated with the value red, right? So because this key existed in the dictionary, it just replaced it. So that's really important to know, right? So you can't have duplicate keys. You would have to call it something else if you wanted it to be associated with a different value. Or if lemon truly does have multiple values, then what you do is you assign the value to lemon as a list that has those two values, yellow and red.
And would you do that just by doing like lemon equals square bracket yellow red?
Yep. So we could test that out by going yellow. Of course, this has to be quoted. And now you see that the value associated with yellow or with lemon is yellow, red. And this highlights another awesome thing about dictionaries. If you're not constrained at all by the values, some of these are single string elements. This one is a list with multiple string elements. I could have other things that are integers, whatever. You could assign the values as whatever you want.
Does the order with which you have it in the dictionary matter?
Yeah, so by default, how does Python order them alphabetically by key? No,
so
by entry. The default.
So dictionaries are inherently unordered. I think when it displays it to you, sometimes I think it's alphabetical if you print it. I mean, it's clearly not up there.
No,
dictionaries are unordered, so you literally can't index them by like a number. You can't go to dictionary square bracket 0. It's gonna be like, I don't know what that is. Give me key. If that's what you're asking.
Kind of, because
right.
I'm using Python too because 3's not working.
Oh. Right.
And so my list looks different than your list, and my lemon is the second thing in there, even though I just.
So this is one of the frustrations with dictionaries. In this case, the elements are ordered based on the order in which I input them, right. And a lot of times that's what Python is going to do. Now, it's really helpful to note that there's a particular module called ordered dict, and ordered dict has a function in it. You could pass it a dictionary, and it'll alphabetize it. For example, it'll order it based on any conditions that you give it. But if you do need your dictionary to be ordered, the solution is actually really simple. So you're not limited to Python's like default understanding of how a dictionary is ordered. You have complete control over how it's done using a simple function from the ordered dict module. Cool. So we could have a bit more about dictionaries down the road, but I want to talk about conditionals for a while. So getting into, for example, the actual interesting stuff that you could do with programming languages. So Python can check whether conditions are true or false. So for example, if I ask Python whether 2 is greater than 1, it'll return true. So Python knows that 2 is greater than 1. In Python, we use double equals to test for equality. Remember, the single equal sign was used to assign values to variables. But if we want to know, for example, if 2 things are equal, so if 1 is equal to 1, then we use 2 equal signs to do that. That will return true. If you use a single equal sign, it'll throw an error. Like it can't assign 1 to 1. It doesn't know what that means. Define this variable 5, and then we could use this really helpful method So if statements in Python are usually preceded by typing if, and you'll notice that when you type that, if is bolded, right? So that's a key word in Python. So when you type that out, Python knows like, okay, something is happening with this if word. So it's expecting something specific to follow. So we could use this cool function called isInstance. You'll also notice that functions show up in light green. They're not bolded, they're light green. IsInstance x an integer. So isInstance is a built-in function in Python. The first argument is the variable or object that you want to test. And in this case, we're testing whether the object x is an integer. And then if statements are always followed by colons. And so if you once you type that colon is, when you press enter, you'll notice that your cursor is now indented by 4 spaces or 1 tab. And this is important. This is how Python reads code, right? When code is indented, it knows that that code is part of the previous line, right? So it tracks those indentations, and that's how you build logic into your programs with these different conditional statements. So in this case, if isInstance x integer, so if the variable x is an integer, if that returns true, we're going to print x is an integer. So the print function could take multiple arguments, each separated by commas. And so what it's going to do is it's just going to combine these. So if we now run this cell, because x is in fact an integer, it returns 5 is an integer. So x is equal to 5, so it returns 5 is an integer. Does that make sense? If we put 5.0 here, it returns nothing. And that's intuitive, right? Because now this if statement doesn't pass. Because f is not an integer, it's a float, this statement returns false, and so this condition is never run. And so this is how you could control the input and output of different things using conditional statements.
Can you specify something if false?
Yep. The way that you would do that is in the same line as if, you would put else. Else print x. Maybe you want to know what its type is. So this would be really useful, right? So x is type x. Right? So in this case, I sort of skipped ahead in the lesson a bit, but in this case, we're saying if this passes true, print x is an integer. So yay, x is an integer. But if it returns false, print x is, and then give me the type of x, right? So if it's not an integer, tell me what its type is. Is that clear to everybody?
Does this float have its own 3-letter code?
No, it's always float.
Okay, so like we could do like if isInstance x comma float, would that return true if we put a float value in the top?
Yep. Well, in this case, you'd want to change that to float, but yeah, that would pass. So we'll leave that variable x defined as a float. I'll just copy this bit down just so you guys can see the difference. But so if x is an integer, return x is an integer. You're not limited to just having else. You could have this other keyword, elif, which stands for else if. So you could just string many, many, many conditionals together. Like you could have, 100 elifs if you want before finally getting to else, right? So elif, you could just keep stringing on conditions that you want to check for. So elif, you need to specify the condition is instance x string print x is a string elif. So if it's not an integer and it's not a string, print x is not an integer or a string. And then you'd probably also helpfully want to know what x actually is. And so you'd put like type x at the end. So if we run this, we know that x is a float, right? And so conveniently, by that logic, it should fail this check because it's not an integer, fail this check because it's not a string, and instead return x is not an integer or a string. And so that matches with our intuition. Still good? Sweet. Cool. Well, that was a quick introduction. That's basically all there is to if-else statements in Python. It doesn't get more complicated than that. You can make these conditions incredibly complicated. You could say, if is instance x integer or this and that, right? So like if you add and here, you'll notice that and is bolded. So it's a keyword. So you could add additional conditions in the same line. So you can check multiple things simultaneously, each of which has to pass for that whole condition to pass. Or if you want them to be exclusive, you can use or.
You still have to put, like, would you write and this instance?
Yeah. You have to specify the condition is in full each time.
You don't have to write the answer down. You don't have to write it.
Yeah. All right. For loops. The things that really suck in R are beautiful in Python. For loops allow us to automate repetitive operations. So for example, let's say we had this list, nums, 1, 2, 3, 4. So this list is made up of 4 elements. We'll run that. So we could check these individually, right? Let's say what we want to know. We want to know if the element is even. So for each element in that list, 1, 2, 3, and 4, we want to know if that number is element or is even. So we could check them individually by indexing them, right? We could, for example, do print nums 0. So check the first element, use our modulus operator that returns the remainder of dividing by 2. And in this case, there's a remainder of 1. And then we could do the same for the second element, 0. And so on and so forth for each element, right? That's fine if your list is only 4 elements. But what if you had 1,000 elements in this list? Are you going to type out 1,000 lines of code checking each one independently, making sure your indexes are in order? That's pretty tedious, right? So this is where for loops become really helpful, right? So for, it's a keyword, so it shows up as bold. Number in nums, colon. So it's helpful here to think about number is a placeholder for the position in the list. So for the first run through this for loop, number is going to be equal to 0. It's going to be equal to, yeah. So it's just basically going to go through the list element by element, right? For the whole list. And in this case, we want to check if each element is even. So we need to include some sort of conditional, right? So if number, so if that element modulo 2 is equal to 0, print number is even. So let's just take a minute to think about what we're doing here, right? So we're iterating over each element in the list. So the first pass, it's going to be 1. The second pass, 2, then 3, then 4. It's going to check if that list element, if that number, when divided by 2, returns a remainder of 0. If that's true, we know the number is even. So we print, yes, the number is even. And then, of course, we could say else print number is not even. So if we run this, we have 4 lines, right? Because it iterated over each element in that list, and then it returned and printed what we told it to print. So 1 is not even, 2 is even, 3 is not even, 4 is even. Yep.
Can you use the same thing in dictionaries, like to search for everything that's yellow?
Yeah. Yeah. Yes. So for example, for key in fruit colors dot keys. So in this particular case, what I'm telling it to do is iterate over all of the keys in the dictionary. And then you could, for example, print key colon fruit colors key. So in this case, this is, wrap your head around what we're doing here for a second. So we're iterating over all of the keys in the dictionary, right? So fruit color dot keys is saying only the keys that are in fruit colors, iterate over each of them, and then print that key and the dictionary indexed at that key, which is the value, right? If you run that, it prints them all out. Iterating over dictionaries is intuitive, but it takes practice, right? So there's another way to do this as well, and this is getting a little bit more advanced, but we'll do it anyways. For key value in fruit colors dot items. So dot items is everything in the dictionary, the keys and the values. And so what we're telling it to do in the for loop here is separate the keys and the values by adding 2 placeholders here. Because maybe it's more helpful to actually see what it does. So fruit colors dot items on its own returns tuples, right? The first element is the key, the second element is the value. So when you parse out each of those tuples in a for loop, you need 2 placeholders, 1 for the key, 1 for the value. And then in the next one, the key, the value, the key, the value, so on and so forth, right? So because the thing that we're iterating over itself has nested elements, we need, if we want to capture both of those elements, placeholders for each of them if we want to use them in our for loop in some way. And so in this case, we could return the same thing that we did above by just doing print key value. Because now we don't have to index the dictionary with key, because value is a specific placeholder that's associated with the value now. And so if we return that, it gives us the exact same thing as previously. So to your question, if you want to return all of the things that have yellow, what you would actually have to do is parse it in this way and then say if value is equal to yellow, then return the key value pairs, for example. Or if your elements are lists, you could say, for example, I'll just do it, if yellow in value. And it'll just return the elements that have the word yellow somewhere in its value, whether it be as a solo string or as an element in the list that is the value. Does that make sense? So, I mean, it gives you a ton of power to basically parse these things out in whatever way you want.
It's a bit more advanced, so if else you don't fully get what's going on with the tuple, we can talk about that more after class.
Yeah, it's
a bit more advanced.
But the point is that it's doable, so it's pretty cool. Finally, I think this is all we'll have time for at the end, which is fine because the some useful packages bit of the lesson, like NumPy and pandas, a lot of the stuff there is more intermediate, so we could actually develop that lesson more in full and then teach it because NumPy and pandas are two of the modules that I think everybody in this room will use if you're dealing with data in any kind of way. It's what allows you to like read and write CSV files and access data in different ways and like create arrays and all kinds of stuff. So we could devote a different lesson to that at some point.
And the problem is actual data analysis. This is kind of the dry stuff you have to understand in order to get to that. But then once you get there, you make all sorts of crazy plots.
So functions. So we already used functions. We use the print function, the isInstance function. Like those are functions that are exported with Python. But you could write your own functions, for example. So let's say we had x equals 5, y equals 7. And we wanted to know what the sum of the squares of those two numbers is. Well, one way to do that would be to print out x squared plus y squared. Kind of a matter of preference, but it improves readability if you add spaces around your operators. So we could do it that way, right? So the sum of squares of these two numbers is 74. But what if we were trying to do this on two numbers, we don't know their values? What if we wanted a generalized function that we could apply to any two numbers we give it, right? So what if we're going to be doing this many times, essentially? We want to define our own function that returns the sum of squares. So you could do that in Python really easily. Just create your own function to do different things. So the way that we do that in Python is by using the def keyword, which stands for define. So we're now defining a function. So we're going to define a function that we're going to call sum of squares. Please give your functions intuitive names. Helps everybody. So it takes two things, num1 and num2. Also give the arguments that a function takes intuitive names. In this case, reading the function name, you know what it does. It returns the sum of the squares. And you also have an intuitive understanding of what its arguments are. One number and a second number. If we had just put x and y, we don't know what x and y are, so it's just not really clear. For every function, you could document it using 3 single quotes. And the minute you type 3 single quotes, it'll add the second set of 3 single quotes. So Python knows that you're trying to document your function. You're trying to write something about it. So int. So this may seem complicated, but basically all it's saying is that the two arguments this function takes are integers, and this function returns an integer. So you're specifying the inputs and outputs of this function.
This is kind of like the standard style of documentation.
Yeah, it's helpful to note that there are different ways to docstring or document Python functions. You could use like the Python style guide, the PEP8 style guide of documentation. Google has its own style guide for documentation. Like
generally, not something you're gonna have to worry about too much unless you're reducing your set of other people use. But it's also helpful for yourself when you write something, come back to the year, you need to read up on what that function does.
This is also make sure that like if you put anything other than an integer in there, it's
So
no.
That's a good question. It doesn't actually check that for you. You have to code that into your function. That's actually one of the practice problems doing that. So no, just writing that there's a reference for yourself. Someone could insert a string there and get all sorts of errors.
And then you just use those inputs, specify the output, right? So the sums of squared out, which is just what we're calling the variable. You could call it whatever you want. Output, for example, although that's not very descriptive. And just say it's the square of the first number plus the square of the second number. And then what you do is you return, Jesus, SS out. Oh yeah, you don't, there's no equals there. Makes sense. And then you just press enter, or well, shift enter. So you run the cell. So now this function that you've defined is created in the environment. So you could actually use it now. Maybe you've already forgotten what it does. So you could, now that you've written this documentation about it with this doc string, you could ask Python, what does my function do? And it'll tell you, right? It'll use that doc string, parse it, and then tell you exactly how the function is used. So now you're in the business of creating your own functions. And then finally, maybe we want to use it to create some output. So output equals sum, go up, sum of squares x, y. So we'll pass in those numbers that we did earlier. And then print the output. So we're assigning the return value of this function to this variable output. Right? So if we didn't assign it to output and we just ran the function, it would just print out the output. It would just return it immediately under the cell. But in this particular case, we're actually assigning whatever this function returns to this variable called output. And so if we do that, we see that it's 74. The beauty of this is that it works with any two numbers, right? Because now we could just do sum of squares, let's say 304 or 576. We could just give it two numbers and it'll just give us the sum of squares of those two numbers. And so you could define really complicated functions that do different things, essentially. And that is right on time. So I'm not going to go through, yeah.
How to keep track of the functions that you create to call them easily. So if you create several functions and later in another session you want to use these functions, can do you have to run them again or you can call them back?
So if you're working in the same Jupyter notebook, it's helpful to just have a cell at the top where you define all of your functions. Run that cell and then they're all defined and you could use them anywhere in the notebook. If you want to create your own functions that will work in other scripts, other notebooks, other locations, that becomes a little more advanced. So what you have to do is, the easiest way to do is you could combine them into a single script and then import that script into other Pythons using import. So import is a key word in Python that allows you to import modules or scripts. So you could import your script from wherever it is on your computer and actually use the functions that are contained in it.
So an R analogy would be, so in R we have library for packages and source related scripts. In Python, import works for both. So you can type in import pandas for the pandas package, but you've also written a script called my functions. You can type in import my functions if it's in the same folder and full other functions. Now
it gets into something a little more complicated, which is that when you use import, Python is looking in specific locations in your computer for Python packages. So if your module is not in the place that the computer is looking, it's not going to find it. So you have to tell Python where to look for it if it's in a different location.
Define a directory, your working directory, or
in a case like that, if you're importing stuff, you wouldn't want to define a working directory because a lot of the other stuff that you're using might not be in that directory. There are ways around this. So Conda is really good for this. Conda has a built-in way of managing your directories for you for different projects by isolating them. So you could have a Conda project, let's say Conda chapter 3 environment. all modules, scripts, everything associated with your chapter 3 thesis live in that environment. Nothing in there is accessible outside of that environment. Then you have a separate self-contained environment for chapter 4. All of the dependencies and scripts and stuff and data associated with it in that environment. The alternative in your case is if you know you're going to be using so often, is you actually just create your own Python module and install it on your machine, and then it becomes accessible in the default locations that Python looks for it.
Writing a library, adding a library.
Yeah, so like the equivalent in R would be like installing it using disutils and having a description file and that sort of thing. In Python syntax, you could have a requirements.txt file and then like a setup.py that you run and it installs it system-wide. We could have lessons on that too. I did it for a previous project of mine, and yeah. But that's all I have for today. Like with everything you guys learned about Python today, to be honest, that's most of it. Like with these data structures and just understanding basic conditionals, like you could do a lot with different types of data and start building pretty complicated stuff. The next Python stuff will sort of build off of this and go into more specific modules that might be helpful for you guys, and more sort of specific syntax things that are helpful in sort of understanding methods and different functions. And yeah, but we'll do R in 2 weeks. And then if you guys are working on, like actively working on coding stuff, we'll have like a 3-hour coffee and code session next Tuesday that I'll email about. Feel free to just drop by with whatever you're doing. And we could go through whether it's R, Bash, Python. I think we said 1 to 4.
1 to 4, yeah.
So 1 to 4 next Tuesday in the grad lounge. So just stop by with whatever you're doing and we could just like, yeah, troubleshoot some code and do stats or whatever. Thanks for coming. Yeah, that's why we started with Python. Yeah.
Guys, any quick things? Sorry, I didn't just end up with 2 notes because I'm talking. Sorry, but at the end of the notebook or like the reference material, there are some practice problems to practice like some of what we covered, some more advanced.